Coming to the next question. Here you can see an army contingent of 616 members is to march behind an army band of 32 members in a parade. You might have seen this in Republic Day parades and in Independence Day parade. You know that there is an army band. There will be an army band going ahead, and behind the army band, the army contingent has to march. Normally it's happening like that, right? You know it, you're familiar with that, right? You have seen it. Plenty of you might have seen it, at least in television we have seen it, right? So here it's perfectly numbered that the total army contingent, it consists of how many members? 616 members. This is the given data. Keep that in your mind. This is the given data. Now there are 32 members in the army band. Those who are going to blow the band, those who are going to lead the band, inside the band they are having 32 members. And now this army contingent, they have to march behind this band, means band has to go forward and behind them they have to come. That is the first statement which is given in the question. That much did you got it? That much did you got it? It's very important. Understanding the question is so important. That's why I'm asking like this, okay? So you got that much, right? Keep this in your mind. Now what is the next sentence given? The two groups are to march in the same number of columns. These two groups are to march in the same number of columns. Means how much number of columns are there in army contingent, that should be the same number of army band. Both of them should march in exactly in the same number of columns. They should not go like this from here and there. If there is a little bit line, then we have to take it from here, take two soldiers and keep it there. It's not possible because both of them are entirely different, right? They are supposed to blow the band. Here they are supposed to march. Both of them are having different programs. So definitely we cannot mix them up. So anyhow, even if they are going behind them, what is our question? They must go in the same number of columns. So our question is the last line. Read the last line. What is the last line? What is the maximum number of columns in which they can march? What is the maximum number of columns in which they can march? So you have to find the maximum number of columns. Whenever you are hearing the word maximum number of columns, that means simply we can say you have to find the HCF of these numbers. What are the numbers? 616 and 32 are the numbers. So now let us get into the solution. Whenever a question is given, whatever data is given, that will be in the first 2-3 lines, and the last line will be your question. Actual question means whatever is given in front of you to be solved, that will be given in the last line. Before the last line, whatever things are given, that's the data which leads you to the solution. Clear? So that data should be there inside your mind, and you must be aware of the question also. So last line is our question. What is the maximum number of columns in which they can march? Okay, so let us find it out. So first of all, what is the given data? Let us copy down. First of all, what we will write? Given that strength of army contingent is equal to 616 members. Strength of army band is equal to 32 members. Next line, what we will write? The total number of columns or the maximum number of columns is equal to HCF of 616, 32. Even though we are pronouncing it like that, HCF of, but when we are writing HCF and within the brackets only we will write like this. Within the bracket only we will write. Clear? So within the bracket we are writing 616, 32. That means you have to find the HCF of these two numbers. How will you find the HCF of these two numbers? Right now, in the previous question we have discussed about that one by using Euclid's division algorithm. So let us go forward. So what is Euclid's division algorithm? Among these two numbers, whenever two numbers are given, you have to choose the bigger number. Here the bigger number is 616, right? So we will write 616 is equal to, what is the second number? It was 32. So 32 into how many times? Just divide it and see how much times? 19 times. So 32 into 19 plus it gives a remainder 8. So as the remainder is not 0, we will have to again follow the same rules. Again we have to repeat the same steps in the next step. We have to repeat the same algorithm in the next step. So now 32 will come here. So 32 is equal to that remainder 8 divided by 8. 8 into how much times? 4 times. 8 into 4. It's 32 itself, right? Plus, that means there is no remainder, plus 0. So now you got the remainder as 0. I told you, whenever you are getting the remainder as 0, you will have to stop exactly there. And now it's time to select the HCF. What will be the HCF? The HCF is 8 itself, right? In the last step, whatever comes here, that divisor will be your HCF. So here the divisor is 8. So obviously we will take the HCF of 616 and 32 is equal to 8. We got it. But let me ask you, in the question, did they ask to find the HCF? No, right? We found the HCF because we need the maximum number of columns. That's why we found the HCF, because we got the idea that if you want to find the maximum number of columns, we have to find the HCF. That's why we done it, right? So here, even though we got the answer, we have to conclude it to the final step. What will be the conclusion step? What will be the final step? We will check out the last line of the question. What was the last line of the question? What is the maximum number of columns in which they can march? So here we will conclude like this. Therefore, the maximum number of columns that they can march is equal to 8 columns. Like this you have to write. Step by step you have to write. It's very important because in 10th class, when you are going to your final exams, when you are preparing your final exams, the paper are checked in step marking system. For each step there will be answer. Simply, even if you just read that question and you understood that one, means you want to find the HCF. Simply, if you're taking HCF of 616 and 32 and you found it as 8 and you put 2 lines over, you got the right answer, but you will not get the full marks which is allotted to that question. Only for your answer, they may be giving only 1 or 2 marks, even though the question contains of 4 marks. If the question carries 4 marks, if you want that 4 marks, you have to follow all the steps. So first of all, whatever things are given in the question, you have to copy them. You have to copy the data. Then what is given, means what is to be found, and what is the way to find that answer. That's what here it is as HCF. You got it. And after getting the answer, then you have to conclude it by reading the last step of your question. So here we will conclude, as I said, the maximum number of columns is equal to 8 columns. Hope you understood. Next question. Use Euclid's division lemma to show that the square of any positive integer, is of the form 3m or 3m plus 1, where m is some integer. So here what you have to prove, 2 things you have to note. 1, 3m plus 1. That means in your mind it will come, you will have to divide it by 3. Clear? That much you got it. One more thing which is very important, means the square of positive, it's not any positive number, it's the square of positive integer. It's the square of positive integer. Forget not. That these 2 things you have to watch very carefully. Read the question very perfectly, because every question may seems very alike, but actually they are not. So here it is the square of a positive integer. So how will we start our question? Normally, as we start for proving, the first step will be obviously like that itself. Let n be a given positive integer. We are choosing it as n. Let n be a given positive integer. On dividing it by which number? 3. Why we are using 3? Because here you will have to use 3m and 3m plus 1. That's why we are using 3. I already told in the previous question, right? So here we will be using that same 3. So on dividing it by 3, let q be the quotient and r be the remainder. Normally this will be the common step for everything. Hope you understood that much. What will be the next step? On applying division lemma. On applying Euclid's division lemma. That's the next step. On applying Euclid's division lemma. So in this equation you have to apply Euclid's division lemma. When applying, what you will get? N is equal to, tell me, 3q plus r, where 0 less than or equal to r less than, what's the number? 3. Here it is 3. So now 0 less than or equal to r less than 3. That means The possible values of R are 0, 1 and 2, not 3, because it should be less than 3. So there are 3 possible values. So next step we will write the possible values of R are, what are they? 0, 1 and 2. These are the 3 possible values of R. Now you have to check the square of the number, right? So here n is the number which you have assumed. Now next step, n square is equal to, what about n square? Take the square of the RHS also. What is the RHS? It is 3q plus r. So take the square. What will it become? 3q plus r the whole square. That means it's of the form a plus b the whole square. Instead of a, 3q came. Instead of b, r came here. So using that identity, how you will write? That is equal to 9q square plus 6q plus r square, comma 0 less than or equal to r less than 3 itself. So you got this, frame this equation, keep this in your mind. In this equation, we are going to apply the values of r. We are going to substitute the values of r. Initially, what is the value of r? It is 0. So let us take that one. When r is equal to 0, what will be the equation? The equation will become, when r is equal to 0, n square is equal to 9q square, because the remainder part will become 0. 9q square. That is equal to, inside this 9, let us take 3 outside. So 3 into, within brackets, the leftover within brackets, 3 into, within brackets, what we can write? 3q square. We took the 3 outside. Knowingly we are taking this 3 outside because, see the question, we have to prove it as 3m. So we have to bring it in 3 into something. M is any integer. M is any integer, right? For some integer m, that's what the question means. So the second part is an integer, that's all. It may be any integer, it doesn't matter. But the first part, it should be of multiple of 3. So we have to bring that to that model. That's why even though if we got 9q square, we are bringing that to this model. How we will write? 9q square is equal to 3 into 3q square. And this 3q square, we will keep it separately within brackets. Now tell me, what is this q? Q is an integer, right? So q square, that will be another integer. That multiplied by 3, that will be another integer. Means it is some integer, we don't know what it is. It is a variable, right? It's a varying quantity. So whatever values you are going to give to q, it will be that, it will be using that value. That means 3q square, all together we can say 3q square is an integer. And we already in this question, initially we have taken that for any integer, we will take it as m. So this one we will conclude, we can conclude like this, that is equal to 3m, where 3q square is equal to m. We are assuming that 3q square is an integer like that. So it's of the form 3q. You got it. Now let us go to the second value. Give the second value. What is the second value? R is equal to 1 is the second value. Now give the second value. When r is equal to 1, what will happen? N square is equal to 9q square plus 6q plus 1. Right? When you are giving the value of r as 1, you are getting this one. That is equal to, see the first two things. Inside this one, 9q square, then 6q, then 1 is there. 9q square, 6q. You can take 3 as common, right? If you are taking out 3, if you are bringing out 3, then 3 into, what you can write this one? 3q square plus 2q within brackets, plus 1. So what about 3q square plus 2q? 3q square is already an integer. 2q will be another integer. Integer plus integer, it will become another integer. So definitely the thing which is inside this bracket, that's gonna become an integer itself. So we can assume it as m. We can call it as m. So next line, that is equal to 3m plus 1. Where m is equal to, what is m? M is equal to 3q square plus 2q. We assumed it as an integer. Now let us give the third value. What was the third value? When r is equal to 2, let's give that one. What will become? When r is equal to 2, n square is equal to 9q square plus 12q, 9q square plus 12q plus 4. 9q square plus 12q plus 4. See, anyhow towards the last you have to bring plus 1. Is it? Towards the last you have to bring it plus 1. But see here, in these three numbers, there is nothing which is common that we have to take out and 1 will come. It's not going to happen like that, right? You know that in these three numbers, nothing is common. So you have to make this in such a way that 1 should come out. 1 should be coming out from this one. How can you take out 1 from this one? You can split 4. How can you get 4? You can write it as 3 plus 1. So automatically 1 will come there, right? So knowingly we are doing this one. There is no further explanation for this one. So as to bring this one outside, we are splitting that 4 as 3 plus 1. Clear? If it was 5, we will write 4 plus 1. If it is 6, we will write 5 plus 1, like that. That's it. So here it is 4, so 3 plus 1 we are going to write like this. So next step, instead of 4, we will write 3 plus 1. Now, from this first 3 terms, 3 is common. Bring it out. If we are taking 3 common, what will happen? 3 into 3q square plus 4q, right? From 12, if you are taking 3 outside, then 4q plus, next term is 3. From this 3, already 3 came outside, so plus 1. Bracket closed, plus 1 more 1 is there. So what is there within this brackets? Check it out. Everything are integers. 3q square, it's an integer. 4q, it's an integer. 1, it's already an integer itself. So adding them together, that will be another integer. So all together we can say this is m, right? We can conclude it as m. So next line we will write that's equal to 3m plus 1. Now see, there were 3 values for r. R is equal to 0, R is equal to 1 and R is equal to 2. In these 3 values, whenever we gave these 3 values, in the first part we got it as the form 3m. What about the second and third part? We got it as 3m plus 1, again 3m plus 1 itself. So we can conclude that the square of any positive integer, remember the square of any positive integer is of the form 3m or 3m plus 1. So finally we will write that statement, hence proved. Like that we can state this one. Hope you understood the proof. This is how we have to prove something. So 2 things you have to remember. First of all, read the question very carefully. If a square is mentioned, you have to take it as the square. If a cube is mentioned, next question we are going to that one, you will take it as a cube. If nothing is mentioned, if it is simply an odd integer, you have to take it as odd integer. If it is given as even integer, you have to take it as even integer. The next step is, next thing which you have to remember means, what is the question which is asked before you? Is it 3m or is it 4m or is it 5m or is it 9m? What is that number given? Take that same number to divide. You will write, let n be a given number, then on dividing this n by what? If it is 3m, use 3. If it is 6m, use 6. If it is 2m, use 2. If it is 4m, use 4. Like that. So this is the only thing which you have to keep in your mind. If you understood this much, very fast you can prove any of the proof which is given in front of you. So this is the way how to prove this one. Hope you understood the question. So 140 can be expressed as 2 square into 5 into 7. So forget not, every time you have to express it as the powers of primes, if powers are available, okay? Never multiply them 2 into 2 and write like that. You have to express them as the powers. Going to the next question. What is the next question? 156. That's also an even number exactly divisible by 2, starting with 2, because every time you have to divide by the least prime number. That's very important. Okay, now let us start with 2. When you are starting with 2, how much times? 78 times, right? 78 will come there. Again, 78 is an even number. Again, we have to divide it by 2 itself. How much it will be? 78. Then, now 39 times, right? 3 and 9 will come there. Now, 39, it's exactly divisible by 3. 3 is the least prime number which is divisible by 39. Now, by 3, how much? 13, right? So this 13 is the prime number. Being a prime number, we will stop it there. And now let us collect all the primes. So we can express 156 as 156 is equal to, tell me, 2 square, right? That means 2 into 2. There is no need to write like that. 2 square into 3 into 13. That's it. Next one, 3825. Right, 3825. Every time we may be thinking that last number as it came as 5, definitely it's divisible by 5. But let us check whether it is divisible by 3 first of all, because 3 is also a prime number which is lesser than 5. So let us check whether it is divisible by 3. If yes, then let us carry with 3. Let us start with 3. Okay. Yes, by checking, we can understand that this number is divisible by 3. How can you understand that one? Just add all the numbers, all the digits, add all the digits. Here 3 plus 8 plus 2 plus 5. Adding all these things, how much did you get? 3 plus 8 plus 2 plus 5 is 15, and that 15 is exactly divisible by 3. So definitely this full number, this whole number will be divisible by 3 itself. Entirely we can divide it by 3. So starting with 3. When you're dividing it with 3, how much did you got? 1, 2, 7, 5. Again we can divide it by 3 itself. How much? 4, 2, 5. What about this number? Add that numbers. 4 plus 2 plus 5. It's 11, right? 11 is not divisible by 3. So definitely this full number is not going to be divisible by 3. That's why, being the last number, as the last digit is 5, definitely it is going to be in the table of 5 itself. So let us start with 5. 5 will be the least prime number. That's the meaning of that one. Okay. Starting with 5. Dividing with 5, you got 85, right? 85. Now 85, again it is divisible by 5. Again divided by 5, you got 17. 17 being a prime number, we are going to stop it right there. We stopped it right there. And now let us take all the prime numbers and let us express it as the product of primes. So we will write 3825 is equal to, come on, 3 square into 5 square into 17. That's the answer. Next, 5005. So let us check whether it is divisible by 3. Adding both the numbers, you can see that the total sum comes as 10. 10 is not divisible by 3. So definitely this whole number is not divisible by 3. So let us go straight forward to 5 divided by 5. How much you got? 1001, right? 1001, 1001. This number, while checking, it's divisible by, which is the least prime number which is divisible by this number? Exactly, it is 7 itself. By dividing it by 7, you will get 143, 143. What about that number? It's divisible by 11. 11 will be the least prime number. So dividing it by 11, how much you got? 13. So again we got a prime number. We are stopping it here itself. Being the prime number, we are stopping. Now how can we express this one? 5005 is equal to 5 into 7 into 11 into 13. There is no powers because no numbers were repeating, right? Okay, next one, the final question of that first section. What's it? 7429. Oh, it's a typical question. Because when you are checking this number, you can understand it. It's not divisible 1 by 2, 3, 4, 5, 6. When you are selecting all these numbers, definitely it's not going to get divided by that, right? So straightforward, let me tell you, this number is completely divisible by 17. So by dividing by 17, how much you will get? 437. 437. Now this 437, that number also is a typical number because it's only divisible by 19 alone. Let us factorize it by 19. How much times? 23 times. Here, 3 of the numbers are extremely bigger number also, right? It's not that much easiest number. So how much did you got? 17 into 19 into 23. So that means we have expressed the given numbers as the product of primes. Clear? This is how you have to express. You have to just divide it and check. Then you will have to copy them. That's all. Hope you understood.